Okay, let's unpack this. Imagine your network, right? It's like this huge bustling city. You've got thousands of people, loads of different devices, all trying to get in, move around, access stuff. How do you even begin to manage that? Keep track of who's who, what they should be allowed to do, make sure, only the good guys get through. It can feel pretty chaotic. So today we're diving deep into network access control. Specifically, we're focusing on a system designed to bring some serious order to that chaos, Aruba ClearPass. And our source material for this deep dive, it's actually pretty interesting. We've pulled insights directly from the knowledge base for the HPE6-A88 exam. And you might hear exam prep and think, oh, great textbook stuff. But for us, it's a fantastic shortcut. These questions, they aren't just about memorizing facts. They really distill the absolute core functions, the critical bits of ClearPass, into these really digestible nuggets. So our mission here is to take these high-value insights and turn them into a solid understanding of how ClearPass actually works day to day. What do its key parts do? And why is it all so essential for modern network security?
We want you to walk away feeling really well-informed, whether you're prepping for a big meeting or maybe you're just like us, kind of insanely curious about how this stuff actually protects our digital world.
Yeah, and what's really fascinating, I think, is how these seemingly technical exam points actually shine a light on the very real-world problems ClearPass is built to solve. It's all about managing network access, which is a huge challenge. So think of it less like a dry test and more like a really concentrated map showing you the practical security and connectivity issues that ClearPass tackles constantly. It cuts right to the chase,
Yeah.
the most critical functions.
Right, cuts through the noise. So if we're trying to bring order to that chaotic network city we talked about, where do we even start with ClearPass? It feels like there needs to be some kind of central authority, doesn't it? Something making the big calls about who gets in and what they can actually do. What's the brain here?
That's absolutely the ClearPass policy manager. You can think of it as the network's dynamic bouncer and chief strategist all rolled into one. Its main job: evaluate every single authentication request coming in and enforce the access policies in real time. The really key insight here isn't just that it makes decisions, but how. It looks at potentially hundreds of changing variables for each request. It's not just asking, who are you? It's asking, okay, what device is this? Is your antivirus running and up to date? Are you trying to connect from somewhere unusual?
Yeah.
This whole adaptive, real-time decision-making thing, that's what really shifts security from just static gates to something more intelligent, like an active defense.
Wow. Okay, so it's like super smart security guard who's constantly evaluating everything, making lightning-fast decisions based on the latest info. That's impressive. But okay, once the policy manager makes a decision, say, yep, you're good to go, or nope, access denied, how does it actually tell the rest of the network? Like the switches, the Wi-Fi access points, how does it communicate that command so they actually enforce it?
Right, good question. That communication piece is crucial. ClearPass primarily uses the RADIUS protocol. That stands for Remote Authentication Dial-In User Service. It's how ClearPass talks to what we call network access devices, or NADs, your switches, your controllers, etc. Now, what's really important here isn't just that it sends the auth info. It's that RADIUS is basically the universal standard for authentication, authorization, and accounting AAA. You'll often hear it called. This means ClearPass can plug into, well, almost any network hardware from any vendor. That saves admins just countless hours trying to build custom integrations. And it ensures you get consistent policy enforcement everywhere, even if you have a real mix of gear. It's kind of the common language, the lingua franca of network access.
RADIUS, okay. The universal translator for network access. Makes sense. So policy manager makes smart calls, RADIUS carries the message. But what specific, tangible actions can ClearPass actually take once someone's authenticated? Or denied even? Is it just a simple yes or no, or can it do more granular things?
Oh, definitely more granular. And this is where enforcement policies really come into play, connecting it all together. An enforcement policy defines the precise action taken after that authentication decision is made by the policy manager. So based on context, like the user's role, maybe the security health of their device, other conditions, it can do some really specific stuff. It could assign a user to a particular VLAN, which effectively isolates them on a separate network segment. Or it could apply specific access control lists, ACLs, to strictly limit which servers or applications they can reach. It can even trigger external actions, like telling another system to quarantine a device if it looks compromised. It really allows for this dynamic, context-aware control. It's much more nuanced than just a simple on-off switch for network access.
That sounds incredibly powerful, being able to apply such specific rules on the fly. But that brings up another question for me. How does ClearPass even know who someone is? or maybe what kind of device they're using to apply those policies so dynamically. How does it figure out those categories in the first place?
Yeah, that's where role mapping comes in. It's absolutely key. Role mapping lets ClearPass dynamically figure out what access rights a user should have by assigning them a role. And it bases this role on attributes it learns about the user, maybe from Active Directory, like their group membership, or based on the type of device they're connecting with, or even how they authenticated. So think of it like a smart ID system. It sees you connect, maybe checks your AD group, and instantly knows, okay, this person is HR staff, or this is a guest, or maybe this is an IT admin. And those roles, they're then used directly by those enforcement policies we just talked about to grant the exact right level of access, no more, no less. And then for the devices themselves, figuring out what is connecting, ClearPass uses a pretty clever technique called DHCP fingerprinting.
DHCP fingerprinting. Okay, what's that?
So when a device first joins a network, it sends out a DHCP request to get an IP address, right?
Right. Standard stuff.
Well, ClearPass analyzes the subtle details within that initial DHCP request data, basically, the device's first bit of network chatter. And based on patterns in that data, it can often detect the device type. Is it a Windows PC? An iPhone, maybe a smart PV, or a network printer? That information is really crucial for profiling the device and then applying the right network policies. You probably want different rules for an unknown iPhone connecting versus a known corporate laptop, for example.
Wow, okay, so it's basically reading the device's digital fingerprint just from that initial network. Hello, that's genuinely pretty cool. So ClearPass is smart about recognizing devices and users that it kind of knows about or can profile. But what about the more unpredictable situations, like say a visitor comes into the office and needs Wi-Fi, or you've got a new employee who needs secure access right away, or maybe someone's bringing in their own personal laptop BYOD. Are there specific tools or modules for handling those first contact scenarios where you don't necessarily have profiles set up already?
Absolutely. For that visitor scenario, guest access, the captive portal is essential. You've almost certainly run into these yourself, maybe at a hotel or an airport coffee shop. It's that web page that pops up when you first connect to the Wi-Fi.
Yeah, the login page where you have to agree to terms or put in a code.
Exactly. That's the captive portal. It's how guests can register, maybe log in with credentials they're given, or just accept the usage policy before they actually get granted access to the network or the internet. It's a controlled, often branded way to smoothly onboard those temporary or unknown users. And then for securely getting devices onto the network, especially personal mobile devices in like a BYOD environment, the ClearPass onboard module is really invaluable.
Onboard, what does that do differently?
Well, instead of making users deal with complicated long Wi-Fi passwords, which can be insecure anyway, onboard provides a secure, automated way to provision devices with client certificates.
Certificates.
Yeah.
Like a digital ID card for the device itself.
Precisely. Think of it like a highly secure, unique digital ID badge just for that specific phone or laptop. These certificates then allow for seamless and secure network access using protocols like 802.1x. The device authenticates silently and securely using its certificate without needing the user to type a password every time. This makes unauthorized access much harder, plus it drastically simplifies things for the end user when they need secure network access.
Yeah, that sounds really comprehensive. You've got the policy manager as the brain, Radius communicating, enforcement policies taking action, role mapping for users, fingerprinting for devices, captive portal for guests, onboard for secure device setup. It feels like a lot is happening behind the scenes. But with all this activity, all these decisions flying around, how do network admins actually keep track of it all? How do they stop it from just becoming a black box? How do they troubleshoot when things go wrong, or just get visibility into what's actually happening across the network?
Yeah, that's a critical point. And that's where ClearPass Insight really comes into its own. Insight is the reporting and analytics module. Its job is to constantly collect and store log data from basically every single authentication event, every policy decision happening across the ClearPass system. It lets administrators generate really detailed reports. You can see authentication successes, failures, track system status over time, monitor user behavior patterns, check how policies are being enforced, essentially get a deep view into everything. And the Insight dashboard specifically gives admins this centralized, often real-time kind of command center view of all that activity. You see logs, alerts pop up, usage statistics. It's incredibly helpful for just keeping an eye on things proactively, but also for digging in quickly when troubleshooting an issue, and crucially for compliance reporting. You have that detailed audit trail for every single network access attempt, which is often a requirement.
Right, that visibility and audit trail sound essential.
Mm-hmm.
Okay, final piece then. For a system this critical. I mean, it's basically the gatekeeper for the entire network, right?
Mm-hmm.
How does ClearPass make sure it's robust? That it can handle the load of a big company network, maybe thousands of connections happening all the time. What happens if one server running ClearPass has a problem? It can't just be a single point of failure.
No, absolutely not. For larger deployments, ClearPass uses a clustered architecture, specifically a publisher and subscriber model. This is designed precisely for high availability and scalability.
Publisher and subscriber. How does that work?
So, you have one node designated as the publisher. Think of it as the central configuration authority, the master brain for all the settings and policies. Its main function is to keep everything synchronized. It pushes out all the configurations, the policies, system settings, even software updates to all the other nodes in the cluster. Those other nodes are the subscribers. They are the real workhorses. They handle the bulk of the actual authentication traffic happening out on the network. They do the local processing based on the configuration they get from the publisher. This distributes the load effectively so no single server gets overwhelmed. And critically, if one subscriber node happens to go down, the others just pick up the slack. The network access control system stays fully operational. This cluster design is really essential for ensuring both that high availability, preventing outages, and making sure performance stays good, even on really large, busy networks.
Got it. So it scales up and stays resilient through that publisher-subscriber cluster. Makes perfect sense.
Given how dynamic everything is today, users constantly moving, all sorts of new devices popping up, new threats emerging all the time, and seeing how sophisticated these access control systems like ClearPass have become, how might understanding these fundamental building blocks actually change how you approach securing your own digital life, even outside of a big corporate network? Think about the implications of really knowing who and what is on your own home Wi-Fi, for instance, or how your own phone or laptop gets identified and allowed access when you're out in public spaces. The core principles we've talked about today, identity, device posture, context, policy, they actually extend far beyond just the enterprise environment. Something to think about.